What's up guys, I'm Double D and today I'll be doing some problem solving. So lately I've been watching a lot of competitive programming videos on YouTube and I watched some coding interview questions and things like that. So these videos inspired me to maybe try and do some of the problem solving on my own. So that's what I'm going to be doing today. Now this video might be a little bit different than my other videos in a sense that most of the time when I record a video, I usually have a script and I research the topic beforehand and I know what I'm going to be talking about. But today is going to be a bit different. I don't really know what problem I'm going to be solving, but here I'm going to try it. I'm going to try and explain my thought process as I'm solving the problem. And yeah, that's about it. Let's get started. So the website I'm going to be using is this one, HackerRank. There's obviously other websites you can use for practicing your programming, but I chose this one. And as you can see, there's a lot of different skills available for practice, like algorithms, data structures, all kinds of different languages, even artificial intelligence, functional programming, and things like that. For today, I'm just going to be doing algorithms. And I'm gonna do an easy challenge called Between Two Sets. So before I get started, let's see how this page looks like. So here you have the problem description, then you have the function description, the thing that you have to write, the piece of code that you have to write, what you have to return, the input format, constraints, and stuff like that. You have the author, the guy who posted this problem, and then here you have the submissions. You can see how other people solve the problem. You have the leaderboards where all the solutions that are submitted are ranked and sorted by a certain criteria. You have the discussions and things like that. I'm not going to open any of these because I don't want to see the solution yet. I want to try and solve the problem myself. And when you scroll down, you have your editor here where you're going to be writing your code. As you can see, you can choose a language. There's all kinds of languages, but today I'm going to be using C++. And this is the function that I'm going to be writing. All the rest of the code is automatically generated, and it's there to handle things like test cases and input, output, things like that. But you don't really have to worry about that. You just have to write this piece of code. And that's about it. You can run your code, you can submit it. But before we do that, let's read the actual problem. There will be two arrays of integers. Determine all integers that satisfy the following two conditions. First one is, the elements of the first array are all factors of the integer being considered. And the second one is, the integer being considered is a factor of all elements of the second array. Okay. These numbers are referred to as being between the two arrays. So I'm guessing that's why the problem is called Between Two Sets. Okay. Determine how many such numbers exist. Okay. So we have an example here. We have an array A, 2 and 6, and array B, 24 and 36. There are two numbers between the arrays, 6 and 12. And here we have the explanation why. We look at the first array, and we obviously know that both of these numbers are factors of 6. And we look at the second array, and we can see that 6 is a factor of both of these. So if you divide 24 by 6, the remainder is going to be 0. And if you divide 36 by 6, the remainder is also going to be 0. That's what is explained here. So in this example, the function should return 2 because there are two such numbers. Okay, so I kind of have an idea already how I'm going to solve this. Let's read the function description. Complete the getTotalX function in the editor below. It should return the number of integers that are between the sets. The following parameters. The first one is an array of integers, A, also an array of integers, B. And it should return the number of integers between the sets. So I think I'm gonna check these two conditions for every number beginning from 1 to, for example, 36 in this example. Why 36? Because any number larger than 36 will not satisfy the second condition. So the maximum range I should go to is the maximum of both of these arrays. Now I'm not sure if there's a function, there's like a built-in function for that, or if I'm gonna have to write the code myself. Anyway, once I find that maximum, I'm gonna go from 1 to that number. Actually, I'm gonna go from 2, I think, because 1 is always going to be a factor of both of these arrays. For each of those numbers, I'm going to check if these two are the factors of that number, and also if that number is a factor of these two. So that's the idea. Before I start writing code, I can read the input format, constraints, and the rest of these things, but I don't really need to do that. I noticed that for most of the easy challenges and easy problems, you don't really need to pay attention to the constraints. But of course, it's good to know them, and it's good that they're available to see. Anyway, enough talking, let's start writing some code. So the first thing I need to do is find the maximum of both of these arrays. Okay, so after a little bit of Googling, I found out that there's a built-in function in the std namespace called maxElement, which takes in the beginning of the vector. So I'm going to take my vector A, begin, and the end of the vector. So I'm going to say a.end. So this is going to return the maximum element from the vector A. I'm going to store that in a variable called maxA. Then I'm going to say maxB and do the same thing. There's an error here. This function returns a pointer to the maximum element. So I'm going to have to dereference that pointer by putting a star at the beginning. And then I'm going to say max equals to max of max A, max B. Okay, I'm just going to change the name of this variable to end. And then I'm going to say something like I goes from 2 to end. So that's going to be my first loop. And for all of these numbers, I have to check both of these conditions. So how do I do that? Well, it's already explained here. It's pretty simple. I just use the mods operator. So for the first condition, I need to check if all of the numbers in the first array are factors of the integer I in this case. So I'm just going to write for j goes from 0 to a.size, and then I'm going to say if aj, actually if I mods aj equals 0. So if this is true, that means the condition is true, and that means that I can continue on. Otherwise, if it's not true, so I'm going to put not true, that means that integer I can never be the number we're looking for, which means we should break the loop. So I'm just going to say something like this. condition is false, and break. Okay, so that's the first condition. The second one is that the integer being considered is a factor of all elements of the second array. So I'm gonna say, I think I'm gonna need another for loop because we don't know that the size of the arrays are the same. So I'm just gonna go ahead and copy this, do the same thing for the second array, and then I'm gonna say the condition is gonna be different. B of j mod I equals, actually it doesn't equal 0, then the condition will be false, and then we should break. Okay, so let's look at what we have so far. We have a first loop that iterates from 2 to the end, which is the maximum element of both of these arrays. In this case it would be 36. And then for all of these integers we check for the first condition, and the second one being, so if any of these conditions are false, then we're going to be here. And actually we can say something like this, if cons, then we can do something, else we can just continue on and go to the next integer. If the condition is true, however, we should increase some kind of counter, which will be our final result. So up here I'm gonna say count equals 0, and here I'm gonna say count plus plus. So this will increase each time an integer meets both of these conditions. If any of the conditions are not met, then this if statement will not be executed, and it will just go on to the next integer. So this seems fine so far. I think this should work, and I'm gonna go ahead and run the code. Let's see what happens. Looks like there's a compilation error. Oh, I think I forgot to return our final result, which will be this variable named counts. So I'm just gonna say return counts. Then I'm gonna try to run it again. Okay, looks like it works. As you can see, there are two sample test cases, 0 and 1. I'm not sure how the input works. We can look at that up here. So the first line contains two space-separated integers, the number of elements in arrays A and B. So in this case, 2 and 3. 2 and 3, okay. And then the second and third line are the arrays themselves. And the output is 3, which means there are 3 numbers that satisfy both of these conditions in the range from 2 to 96. Here's the second test case. And now we are ready to submit our code. It checks all the other test cases. As you can see, some of them are passed and some of them are not. Test case 4 and 7 are wrong. They gave a wrong answer, and all the other ones worked, which means there's something wrong with our codes in these specific cases. So after a little bit of examining my code, I concluded that I made a mistake of always starting the range of integers from 2 to the maximum number. Realistically, I should be starting the range from 1, which means that there could be certain cases where, for example, the first array contains the number 1, and then the number 1 would be included in the solution. So let's put 1 there and try this again. And there we go. Looks like the cases 4 and 7 were specifically for the case where number 1 is in one of the arrays. Looks like all the test cases are passed, and it says congratulations, you can go to your next challenge. Alright, on to the next problem. This one is called climbing the leaderboard. It's the medium difficulty, and for this one I'm not going to be explaining everything in detail like I did for the first one. I just want to focus more on the problem itself and not on the technical stuff around it. Okay, so let's read the problem. An arcade game player wants to climb to the top of the leaderboard and track their ranking. The game uses dense ranking, so its leaderboard works like this. The player with the highest score is ranked number 1 on the leaderboard. Players who have equal scores receive the same ranking number, and the next players receive the immediately following ranking number. For example, we have these two arrays. I'm assuming the first one is the leaderboard, and the second one is the player, actually the player's scores, which we need to kind of insert in this first array and find out which rank they will have. The ranked players will have ranks 1, 2, and 3 respectively. So if we look at the first array, we can see that the first guy with the score of 100 will be rank 1. The second and the third guy have the same score of 90, they're going to be rank 2. And this guy is going to be rank 3. So that makes sense. If the players' scores are 70, 80, and 105, their rankings after each game will be 4th, 3rd, and 1st. And it should return the player's rank after each new score. So it should return an array as well. We have some more sample inputs and outputs down here. And I think I already have an idea how to solve it. If we look at this leaderboard, we can start from this side, so from the rank 1 player, and compare each of the adjacent scores. If they're equal, the rank remains the same, so these two will be rank 1. And then when we compare these two, this one is less than this one, which means that the rank will go up to 2, so this guy will be 2, and so on. So if we take any leaderboard, we should know for each of these scores what rank they are. And once we have the second array, which will be the new scores, which should be inserted in here, we're basically going to do the same thing, except that we're going to be comparing the values of the scores to the new value that should be added. And once we find the right spot, so for example 5 should be all the way over here at the end. Once we find the right spot, we're also going to have the rank number. So that's the basic idea. I'm pretty sure this can be optimized, but I think that's the first thing I'm gonna try out and see how it works. Anyway, let's start writing some code. Okay, so let's see what I have here. I have the first loop, which iterates through the player array, and then the second loop, which iterates through the leaderboard. And for each of the scores in the player array, it checks if the current score which we are considering is larger or equal to it. So if it is larger or equal to it, then we found the rank we're looking for, which is stored in this variable current rank, and we should just break. Otherwise, if it is not greater or equal to it, then we should continue on, and we should update our previous score and go on to the next one. You would remember the ranks, so this rank right here would be, let's see, 1, 2, 3, 4, 5. And then since it's the end of the array, it would put 50 at the end and give it the rank 6. So that is correct. Then it would go to the next one. It would do the same thing. And then it would put it right here. So it would check for 60. Is 65 greater or equal to 60? It is. And it would break, and it would give it the current rank, which would be 5. So to me it looks like this would work. Okay, so the first thing I want to do is change this into a while loop. First of all, because there's a break statement here, and second of all, because I need to monitor the state of J, and I need to do specific things if it's the beginning or the end of the array. So that's what I'm gonna do. I'm gonna say J equals 0, and I'm gonna write a while loop. And then I'm gonna say if that isn't the beginning of the array, then I should increment the current rank by 1. And also when I exit the while loop, I'm gonna say if J equals to ranked size, which would mean that it's the end of the array, I'm also gonna increment the current rank by 1. So these two lines should handle the specific cases where the current score should be inserted at the beginning of the array or the leaderboard, or at the end. I'm pretty sure this is correct, so let's give it a try. Alright, looks like it works for these two test cases. I'm gonna try and submit the code. Again, for some test cases it works, and for some it doesn't. But this time, the compiler message says time limit exceeded. So this means that this algorithm might work, but it's not very good. It's not optimized. If we go back and look at the constraints, you can see that number n and m, which is the size of these arrays, goes from 1 to 2 times 10 to the power of 5, which is 200,000 if I'm not mistaken. So that's a lot of these elements. That's a lot of if statements and while loops and things like that. This means that I need to somehow improvise my code and optimize it. So I did two things. Before I even got into the second array, I checked the first array and remembered or stored their scores in a separate array. This array is called the leaderboard. As you can see, this loop right here is supposed to do just that, pre-processing the first array and remembering all the scores in the leaderboard array. So that was the first optimization. The second one, which was even bigger in my opinion, was the fact that I inserted the second array from this side, so from the opposite side, or the end of the first array. And if you look at both of the arrays, you can see that they are sorted, but the first one is sorted in a descending order, and the second one is sorted in the ascending order. So that means that this number will always be somewhere on this side, and then the next one will be somewhere on this side, and then the middle one will be somewhere here, and so on. Obviously makes sense when you say it, but at first it wasn't obvious for me. And as you can see, I tested it out for these two sample test cases, and it works. So let's go ahead and submit it, and let's see how it works for the other 7 or 8 test cases. And there we go. Looks like it works for all the test cases, and I'm pretty happy with the results. Anyways, that's about it for this video. I hope you enjoyed it. I hope you found it interesting at least. And maybe this even inspires you to try and do some problem solving on your own. Anyways, thanks for watching. Let me know if you enjoy this type of content, and I'll see you in the next video. Peace.